एस्टर्स लास्ट कैटेगरी है। इसमें एस्टर्स यहाँ पर पढ़ाते नहीं हैं हम एक सेपरेट होमोलोगस सीरीज के तौर पर, लेकिन बुक इतना इंट्रोड्यूस करती है कि बच्चे को ये आइडिया हो जाए that it's a separate homologous series. ठीक है? As we've already studied how we make esters when we were discussing the alcohol portion, as well as when we were discussing the acid one. Well, this also comes as a part of the esterification, as a part of acid reactions. So हम यहीं से continue करते हैं. Ethanoic acid and ethanol, one is carboxylic acid, one is alcohol. These two react in the presence of few drops of concentrated sulfuric acid, which acts as a catalyst, initiates the reaction for us to वो concentrated sulfuric acid की presence में ester or water form करते हैं. ठीक है? How do we come up with this formula for ester or this name of ester is something that we are going to exercise on the next page. Don't forget that we are using pure liquids over here, but in lab, usually what we do is that we use aqueous solutions. By that I mean कि पेपर में ऐसा जरूरी नहीं है कि यहाँ पर लिक्विड लिखा है तो वहां पर भी आए. हो सकता है कि पेपर में यहाँ aqueous और ऐसा हुआ है पास्ट में जो मैं अब कह रहा हूँ, यहाँ पर aqueous और यहाँ पर भी aqueous लिखा हो. ठीक है? In that case, this entire equation is also correct, because in lab we tend not to use the most concentrated forms of acid or alcohol most of the time. Okay? Though we can do it for this experiment, but we usually don't. And the past papers have this equation as well. Okay? अब अगर हम इसी equation के हिसाब से चलें, let's continue on the next page to see how we come up with a name and the formula. This type is known, reaction is known as esterification. Esterification is the formation of an ester. This one is ethyl ethanoate. Let me tell you that the ethyl part is the one that comes from the alcohol, and ethanoate part is the one that comes from the carboxylic acid. Remember, the one that is named in the end or consists the suffix is the one that is considered as the parent chain name. I mean, has the more importance. However, the more important one is always written last in the name. All right. Let me explain myself with telling you about the suffix. This OAT is actually the suffix for ester. I hope you remember from previous lessons that N is a part of alkane suffix. Eth is not a suffix, it's a prefix for two carbon atoms. In the similar way, "-ile" is a suffix for alkyl group. I hope you remember from the alkanes topic, because alkyl groups do not have a separate topic. They actually are already covered in the part of alkanes. And again, "eth" means two carbon atoms. Now, you would see that this has two names. So it has two prefixes, two suffixes, and all of that. This is a typical example of an ester. हमने पिछली किसी भी नाम में ऐसा नहीं किया कि हम two sets of suffixes or two sets of prefixes भी इकट्ठा use करें. Maybe there were two sets of suffixes, but there were no sets of prefixes, or maybe there were two sets of prefixes, but there were no sets of suffixes. तो ऐसा हमने किया हुआ है पहले, लेकिन ये नहीं किया कि prefixes और suffixes के दो sets use करें. That's because this entire structure can be divided into two parts. One of which is actually a combination or a part to both of these circles I've just drawn. This, as I said earlier, comes from an alcohol, and this comes from a carboxylic acid. How are you supposed to do that? Let's study it on a separate page. I'm going to stop sharing over here, and we're going to share a whiteboard page. We're going to study how to come up with its formula as well as its name. When I talk about its structural formula, I usually tell my students a specific set of strategies. There are hardly 2 to 3 easy steps that you can perform in order to get the correct formula for an ester. As I've already said, the ester is actually a combination or a reaction of carboxylic acid and an alcohol. So it's better that if you start off with the carboxylic acid first, and then you write the alcohol, or you draw the structures in the similar order. Let's say here we were talking about carboxylic acid. So this must be the structure of ethanoic acid. And in case of alcohol, as the example already suggested, this is the structure for ethanol. ठीक है, मैंने जानबूझ के बेटा पूरे स्ट्रक्चर्स बनाए हैं ताकि आपको समझने में आसानी रहे. ठीक? Can you hear me?
Yes, sir.
Okay. So हमारे पास हमारे पास इस केस में एक छोटा सा स्टेप है. If you remember from my previous lessons, I told you that you need to actually revert these structures in the steps. So the first step is to simply write the structures. The second step is reverting alcohol. And I usually don't use the word sideways. Sideways invert या revert करने का purpose मतलब ये होता है कि आप left को right और right को left बना दें. But that you're only going to do to alcohol. आप notice करें कि हमारे पास acid का structure मैं वैसे का वैसा लिखूंगा, उसमें मैं कोई change नहीं करूंगा. As I've said in the rules, and I'm only going to change the structure of alcohol sideways. Left side पहले आ जाएगी, right बाद में चली जाएगी. ठीक है?
जी सर.
ये चीज याद है? ये मेरा ख्याल है हमने पहले भी ट्राई किया हुआ है.
जी सर.
Okay, you gotta take OH out of the acid and H out of the alcohol and add it up to form water. ठीक? And what you're supposed to do in the last step, combine the rest. So it's pretty easy. हमने
Sir, what if we don't revert the alcohol sideways?
तो आप स्ट्रक्चर में से इस तरह से H निकालें कि वो O के साथ वाला H निकले. ठीक है? बच्चे जब साइडवेज स्ट्रक्चर रिवर्ट नहीं करते तो वो सबसे बड़ी मिस्टेक क्या करते हैं कि वो O के साइड वाला स्ट्रक्चर O के साथ वाला ये H निकालने के बजाय कार्बन का H निकाल देते हैं, which actually does not happen. हम वही वाला हाइड्रोजन निकालते हैं जो हाइड्रोजन निकलना चाहिए. ये नहीं कि अपनी मर्जी से कोई भी हाइड्रोजन निकाले. Actually, if you look at the structure of alcohol, आपको अंदाजा होता है it has 6 hydrogen atoms. 3 of them is attached to the first carbon, 2 of them are attached to the second carbon, 1 of them is however attached to oxygen. You can only take the hydrogen out which is attached to oxygen. You can't take a hydrogen out from wherever you like or from wherever you wish. That actually does not happen during the reaction.
Okay, sir.
Okay. So when you combine the rest, you get your correct structure. So this is your correct structure. As far as the nomenclature is concerned, I mean the naming, so the naming rules are also simple. You get 2 to 3 good rules, 2 to 3 rules, and you're good to go with the name. You are not going to make a mistake. In case of the name, the method is a little bit different. We are going to start off with alcohol, and we are going to work with carboxylic acid after. ठीक है?
Okay, sir.
Now, alcohol name was ethanol, and carboxylic acid name was ethanoic acid. These are the original names. What we're gonna do is that we're gonna make some changes to them. In case of alcohol, convert the anol into ion. In case of ethanoic acid, convert the part of enoic acid into NO8. All right. So when you're done with these changes, ethanol is converted into ethyl and ethanoic acid is converted into ethanoate. There you go. There's your name. All right.
Okay, sir.
Now, in this case, remember, alcohol comes first, carboxylic acid after. So this one is opposite to what we did in formula. And this one does not require any reverting. That's how we can differentiate between both. Now, let me just combine the parts for a better idea. This one is ethyl, hence this part of the name. And this one is actually ethanoate. Okay. How are
Yes,
you
sir.
going to know that a specific structure is an ester? If the structure consists of this group, we call it ester group. If you see a structure which is extended to its left side as well as right, but this kind of structure is present somewhere in between, in which you have a carbon doubly bonded to an oxygen, also singly bonded to an oxygen, and there is a carbon chain over here, and there is a carbon chain over here. This is an ester group. Remember, there are supposed to be carbon chains. You can't simply just end them up with hydrogen. अगर हाइड्रोजन से इसे एंड अप करेंगे तो ये एसिड बन जाएगा. इधर कार्बन होने का मतलब है कि ये एसिड है, एसिड नहीं है, एस्टर है. Are we good?
Yes, sir.
Okay. So this clarifies how you come up with the formula, how you come up with the name, and in case if you have an unseen ester in front of you, how would you come to know whether this specific structure is an ester or not? This actually correlates with the whole diagram that we were just looking at when we were at the last page of chapter 10. Do you have any questions?
No, sir.
All right. I've saved it. I'll send it to you on WhatsApp later. Let's get back to the book then.
Okay, sir.
Can you see the book now?
Yes, sir.
Okay. Now, the book tells us a couple of more important things, which I'd like to go through first. Now, this explains the structure, which I already did, so I'm going to move on to the next paragraph. Ethyl ethanate is just one example of an ester. It's actually a family of compounds, but clarifies that this book is telling you it's a part of homologous series. It's one homologous series. As alkenes alkynes, alcohols, or carboxylic acid work. They all have strong and pleasant smells. They occur naturally. They are actually responsible for the flavors in fruits and scents in flowers. We use them for few fruit flavorings and perfumes. A lot of flavors has been written over here with the actual scientific name of their esters, which can give you a pretty good idea that the common short esters are something that we use in daily life for these flavoring agents. And these flavoring agents are actually all around us. You name it, biscuits, toffees, chocolates, my bad, not chocolates, ice creams, so, or any kid materials, lollipops or stuff like that, whatever those are, bubble gums, they're all based on these food flavors. And you can see there are even shorter structures. You would see suffixes, my bad, prefixes such as ethyl or methyl or bute in different cases, which should give you an idea that there are pretty small structures and they can give you really good flavors. However, there might be some bigger chains in there too. All right.
Okay, sir.
Talking about bigger chains, if an ester group is actually a part of a bigger chain, it may be a complex molecule such as fat or oil. Don't forget, we have already taught in this chapter that oil is actually a liquid at room temperature. So an ester, which is liquid at room temperature, can be a part of an oil. And as far as fats are concerned, they are solid at room temperature. So fats are solids which contain the ester group in them, and they are solid at room temperature. We call them fats, as actually the oils do too. But the only difference between them in comparison to fat is that they are liquid at room temperature. Some membrane fibers also consist of ester group such as stearinine. This is a line which does not concern this chapter and does concern the next. In chapter number 11, as written in the page number, we're going to discuss how stearinine is formed by using esters. All right?
Yes, sir.
Good. Any questions from chapter 10? Because this topic, as soon as we complete this topic, we're actually done with the whole chapter. So any questions from chapter 10?
Sir, do we have to learn this 10.7